Guys, Bionic Who here, and welcome to something a little bit new on my channel. This is actually my first mathematics video. Well, not my first. It's my first mathematics video after my introduction video. But this is the video that I said might be coming out on the weekend. Turned out this weekend was a little crazy, but this week it is coming out for sure. In fact, by the time I'm recording this, it's kind of the middle of the week, but I hope to have this out by Thursday or Friday. Anyways, to start off, I want to talk to you a little bit about what this is exactly. So, I'm in a multivariable calculus class right now, and we are going over motion. And specifically, motion is specified or described using speed and acceleration. Now, in order to get speed and acceleration, you need to have specific equations, and especially if we are going and measuring something, say, in 3 dimensions, like for example, this character, Gaming, and his sword skills in Genshin Impact, then we want to go and find an initial equation for this, and then find the speed equation and find the acceleration equation so that we can determine how much force he's putting behind a specific swing. So, to start off with, I wanted to watch this video, and I'm gonna slow it down real quick, actually. But specifically, he's going to swing 4 times, and on the third swing, I'm going to pause it and talk about that. Alright, here we go. So here's swing 1, there's swing 2, and this one right here, he swings around the bottom and up to the top like this. So let me go back real quick to that real quick. I think it's about here. But yeah, swing down and up. So for me, that looked like a singular circle, kind of. But from a 3D standpoint, we could see something that looked a little bit like this. So this is a corkscrew. I'm sure that some of y'all have seen something like this before. But I wanted to show it kind of on a real world to like simulation basis. So like, as you can see, he starts down here and goes up this bend and over to the top, where he then does the flip at the end for the fourth move, which I really haven't showed, so I'll just show you right now. But he flips over the top and slams down. But I wanted to go and specifically calculate how much force was needed to put on his claymore in order to do this move. So, to start off with, I went through and tried to figure out the code to make this corkscrew, and specifically, there were 2 things that I wanted to involve in this. We need a cosine and sine in order to get this kind of circular shape, but then we also need a z coordinate. As you can see down here, actually. So if I measure, so here, this is a better angle to view it at. Kind of keep switching up a little bit, but if I kind of put it at that angle, you can see that there are actually 3 coordinate planes. There's the x-axis, the y-axis, and the z-axis, and these allow us to measure in 3 dimensions. So in order to draw a corkscrew in 3 dimensions, I actually had to go in and do the sine and cosine, which are normal to get a circle. Like for example, x squared plus y squared equals 1 is a circle equation, and you can convert x and y into sine and cosine to get that same sort of thing. because the equation for sine squared plus cosine squared is equal to 1. And that actually happened to be important a little bit later. But after getting this equation and getting this z coordinate over here, the t over 2 pi, then we're able to make this. Now, the important thing that we come to realize from this is this right here. Let me just highlight it real quick if I can, right there. That actually is our original formula. And this is represented by r. So we do something like this. RT equals to a t, or not t, it would be the radius. So, oh, yes, I remembered. Before I get to that, the other thing of how I got the radius is in Genshin Impact, there actually isn't any measurement values, but in real life, the average claymore length is about 54 inches. So I went in, sorry, excuse me, 64. My calculations were off on other stuff before. But with 64 being the length of it, then that also tells us what the radius of this circle is. So if I were to do this again, I would probably change this to a 6 and then rerun this code. Let's do that. And that gives us a wider radius, as you can see. So from there, we can go and then plug this in and say, okay, RT, which is the original way to format this equation. It's the equation before speed and acceleration. It's formatted as 64 cosine of t, comma 64 sine of t, and then lastly t over 2 pi. So this is important because what this equation really is it's giving us the x, y, and z coordinates. So for example, with the values we had here going from this bottom to the top, we would have something like 0 is less than or equal to t, which is less than or equal to 2 pi. So what we would go and do is we would then plug this into here. So like 64 cosine of 0, 64 sine of 0, and then 0 over 2 pi. And that would get us the coordinates of where this is on this graph. Now next up, what we would then do is go and discover the speed equation and then the acceleration equation. So speed is represented by velocity. Right. The first one is called position. It's position, velocity, and acceleration. So our acceleration is represented by a vt, v for velocity, and this equals to a negative 54 sine of t. Oops, I put that as 1. T, I keep putting 54, it's 64. And then this is a 64 cosine of t. And then the last one is, oh right, this first one is actually times by height. Sorry, excuse me. So this is times by height. The second one, because of the height, is just t over 2 pi. And then this kind of follows that same format where you would go and plug in this range into here to get the speed, but the important thing for us when figuring out force is getting the acceleration equation. Now, before I move on to what the acceleration equation looks like, I'm actually gonna type up a short little equation down here. It's F equals m times a. Now, is force is represented as the F here, and this is just a simple way of showing the force equation. But force is equal to mass times acceleration. So not only will we need to get the acceleration at which Gaming is moving his blade at, but also we'll need to calculate what the mass is. Now, fortunately, as well, once we get to the mass, I wasn't able to find any sort of differences in gravity or things like that. I'm sure that there's some subreddit out there that has more information about this. But, anyways, to move on from this, we then move on to the acceleration equation. So, the acceleration equation kind of takes an interesting turn because I should probably explain this. So, jumping back into this a little bit, when we are doing trigonometry and when we are doing derivatives are like the different equations. So, like, VT is the derivative equation of RT, and a derivative of a trig value, such as cosine or sine, which are the most common used ones, are done in a very specific order. So you have sine first, then cosine, and then cosine's derivative is negative sine, and then negative sine's derivative is negative cosine, and then that just goes back on the cycle while it's on its own. So it goes back to sine again. But from that, we can see that this last equation will be negative 64 sine, not sine, negative 64 cosine, excuse me, t, comma, negative 64 sine t, and then since it's t over 2 pi and t is represented as within this range, then this technically counts as a variable right here. This technically counts as a whole number. And so because of that, the derivative of any number is just equal to 0. So we would just put that in there as 0. So from our acceleration equation, what we then get is I was just double checking my mathematics. From our acceleration equation, we get this. And when we plug this in, what you would go and do to get an official acceleration is you would go and do something like this. So let me just say acceleration equals to the square root of 64, oops, sorry, negative 64 cosine of t. And then this is, hold on, let me add another parenthesis here, because this is squared. And then you add this to, I'm going to copy this to make this a little easier. Control C, Control V, to sine of this squared. And then we're adding this to 0 squared, which is just 0, so I'll just leave that as 0. But last time when I was talking to you about the cosine and sine equation, this is where this important equation comes in. Because cosine squared t, I'm just gonna say it out loud, cosine squared t plus sine squared t is equal to 1. And so because it equals to 1, we just have negative 64 squared. And so because the negative 64 is squared and then there's also a square root, then we actually end up getting a positive 64. So I'm just going to put 64 down there as the acceleration. A equals to 64. Now we can start working on our mass. So according to online, the average mass of a claymore is about the length of it times 0.1. And 0.1 is about, so it's 0.1 of a pound. So with the 64 inches, we times that by 0.1 pound, and that gets us to about 6.4 pounds. So now that we know the weight, what we next need to do is we need to get the mass. Now I want to show y'all something important. After we get our acceleration of 64, then we need to work on our mass. So I wanted to pull up this page for y'all to point out something important. Mass is not the same thing as weight. Now this is really interesting, and I want to re-emphasize this point once again. Mass is not the same thing as weight. This is important because the weight of an object is the object without really any force on it. It's the density of the object multiplied by the volume. Now, we don't need to get that because we already have the weight of the object, but it's important to recognize that that is the object on its own without any gravitational effects. Now, the important thing is when calculating your mass is then finding a gravitational force to put upon it. In this case, though, with Genshin Impact, there might be some subreddit out there where some person has figured out exactly what the gravitational field is on planets of Teyvat. But for our purposes today, I will just be taking this measurement right here, the 9.8 meters per second squared, which is the gravity of the Earth. Okay, so first what we'll do is we will take the 6.4 pounds and multiply them by so 6.4 times by the 9.8, and this equals to about a mass of 62.22. And I'll just label this with an M so we know that that's the mass. And then after that, we can move on to this equation down here, the force equals mass times acceleration. So since we have everything now, let's put this up. Let's go 64 as the acceleration multiplied by the mass, which is equal to a 62.22, whoops, 0.22, which equals to about 4,014 newtons of force. And newton is just the unit of measurement for force. So, from all of our calculations and everything that we saw up here, my overall conclusion for this is that Gaming, with his strength and with the time that he spent to swing, which in this video, if we actually go back to, I think it's 29, yes, 29 to 30, takes about 1 second for him to do that swing, which makes it easy. It's inches per second. This is inches per second, excuse me, inches per second. And this would probably be squared. But with these two measurements, we now know that Gaming, with that move, with that third move in his swings, has to use about 4,014 newtons of force to move his blade from that bottom position we see him in all the way up to the top for him to begin that final swing. All right. This actually took quite a long time, and so I wanted to thank y'all for your patience in waiting for this project to be finished. I also wanted to let y'all know that I had talked about doing the SAS project soon, and a lot of other things have come up, but I hope to be able to get it out before the end of this year. But as for final stuff with the end of this video, two things. One, I'm going to be continuing to release Genshin Impact videos every single week when I can, because I think that they're really enjoyable, and from what I've seen, y'all are enjoying it too. But also, I wanted to make a quick announcement. This won't be a every week sort of series, but I recently saw this game on Steam called Reverse 1999. But it says Reverse 1999 is a 19th century time travel strategy RPG developed by Blue Poach. As a timekeeper, the observer of the eras, you will embark on a journey across time and space, from the roaring 20s to the turn of the millennium, uncovering the truth about the storm and the mystery of the year. I saw this as a recommendation for games like Genshin Impact, and I figured that I might give this one a try. And so, if y'all are interested in seeing that, and just about as excited as I am to start up a new story alongside Genshin Impact, then feel free to like this video and comment. Make something like, "Hey, I'm excited for Reverse 1999," or even, "Hey, I've played that before. You should and recommend me like some tips or things like that since this is a new game for me." But once again, thank y'all so much for watching this video. I truly hope you did enjoy, and I will see y'all next time.